Hello everyone. So here we have problems from work, potential energy, kinetic energy, and so on. Uh, Problem number 8. Please read the given task and then I can show you how to solve it. So basically in this problem we have a suitcase which is pushed by external force F, and it has coefficient of kinetic friction between ramp and inclined surface is given, and it has been traveled 3.1 meter along the ramp. So we have to calculate the work done on suitcase by the force F. In this problem, basically, it in general asks a couple of questions. So first question will be, what is the work done on the suitcase by the force F? Okay. Then another question will be, what is the force done on the suitcase by the gravitational force, Fg? And then they may also ask, what is the work done by a normal force? And then another question will be, what is the work done by friction force? So all of them has to be calculated separately. However, if it asks what is the total work done on suitcase, then you have to add all this work which was done by different forces. So let me explain it. So here we have a ramp, we have a suitcase here at an angle of theta. So first of all, we have to draw a free body diagram for particularly that suitcase. The first force will be our applied force, which is F. Then we have mg, the work done by gravitational force. Then we have also friction force. So let me also draw it here, kinetic friction force. We also have the normal force, which is perpendicular to the surface. So the work done by acting force or by the F force is defined by the force times distance. Okay, and since the displacement and the direction of the force in the same direction, we will get a positive work. Okay, so force is 165 Newton multiplied 3.1 meters, so you got 511 joules. Now, what is the work done by gravitational force? So the gravitational force will be pointing downwards, and then we know that this angle will be theta. So this force can be resolved in two components. One will be mg cosine theta, which is this one. Then this one will be mg sine theta. As you can see that direction of the gravitational force in the parallel to the ramp is opposite to the displacement, because displacements will be in this direction and our gravitational force component will be in opposite direction. So therefore you have to multiply Fg to the d, and also don't forget to put the negative sign. Why? Because as I said, the direction of the gravitational force component is opposite to the displacement. Okay, so when you do calculate it, you should get a negative work done by gravitational force. Now, what about the third question? What is the work done by friction? Now, also, as you can see, the friction force is opposite to the displacement. So therefore, friction work done by friction will be friction force multiplied to a distance mu k mg d cosine theta, because the normal force here is equal to the mg cosine theta, which is this component, which is equal to the normal force. Okay, so again, since the direction of the friction force is opposite displacement, you have to put negative sign here. Okay, when you do calculate it. And then third question will be, what is the work done by the normal force? So work done by the normal force, since we know that the normal force is perpendicular to the displacement, then the work done by normal force will be 0. Okay, so finally you have to find the total work which was done by all forces. Then you can say that work done by acting force, which is positive because the direction of force and the displacement is the same direction, negative work done by gravitational force, and negative work done by friction force plus 0, which is work done by normal force. So this will be your total work which was done by all forces.